this is a really interesting factorizing problem that was sent in by someone, so thank you for doing that. I had a really good time doing this. We're essentially looking for values of a such that this whole expression here actually factorizes. So I'd highly suggest that you give this problem a think and give it a go. It doesn't say how many values of a do this, it just says find values of a such that this factorizes, so it's implying there's more than one, but we don't know exactly how many for sure, which is kind of interesting. I would say that factorizes, of course, we could just do 1 times this, but I'm not really interested in trivial factorizations, and I'm also not going to... we don't really factorize with fractions or surds. Like, I know there's ways that you can do that, but I'm going to take this word factorizing to mean everything's going to be a whole number, and it's nothing trivial. So I'm just going to do that. Anyway, I hope that you've had some time to think about this problem. It is quite a good one to do. I'm going to talk you through my thought process now. The first thing you need to think is, well, what types of brackets could actually expand to make something like this? So the first thing that might come to mind is something like x plus y into something else. Now, the issue with this is when you multiply x by anything in here, you're going to get something with an x in it, and when you multiply y by anything in here, you're going to get something and a y in it. So this kind of factorization is never going to make this minus 5. Right? There's a constant here, and everything in this expansion, regardless of what was here, would have an x and a y in it. Unless you messed around with like a 1 over x or 1 over y. But again, that's not really how factorization works in the way that we think about factorization. And also you could just multiply those out to make these squares, and I'll talk about that issue in a second. But eventually you realize, okay, well, I need an x and I need a y, and I probably also need a constant, right? I probably also need a constant, because that way this constant can multiply by another constant, and I'll make this, right? So this is a really hopeful thing to try, because, okay, well, if I put another x in this bracket, then that'll make an x squared. If I put another y in here, then I'll make a y squared, but I'll also make some xy terms. And if I put another constant in here, then I'll make my constant terms. And of course I can make these terms, because if I put a constant over here, x times a constant will give me some stuff here, and so on. So this essentially seems to be a really good blueprint of a factorization, because it's going to contain everything that I need here. X squareds, y squareds, xy's, some x's, some y's, and some constants. So this seems like a really good idea. So I'm going to park this here and say, I'm going to try stuff that looks like this. Now, before I do that, I should probably think about whether there's anything else that I should try, any other general factorizations that I should try. And I can see x squareds here, so I think, well, okay, what if I just put an x squared in a bracket? And now the issue with this is, because the largest power of x in this equation here is x squared, I can't put any x squareds in this one. Or in fact, I can't put any x's in this one at all. Because if there are any x's here, they're going to multiply this by to make an x cubed, and I can't have that. But thinking about it further, you actually can't even put any y's in here, because if you do, you're going to make an x squared y term, which doesn't exist here. And you think, okay, well, sure, I can make an x squared y term, and then I can cancel it out with something else, mate. Except to do that, you would need an x squared over here, and a y over here again, and now you're just making everything terrible, because now you're going to make x to the 4 terms. So this just absolutely doesn't work, and nor does this, and so you can't put x's or y's here. I mean, it's just a mess. You can't do this, and this is the same reason you can't put like a 1 over x or a 1 over y in here to try and cancel these things out, because you could just multiply everything up by x and you'd end up with an x squared, which is just the case we've discussed doesn't work. So I'm pretty confident that this kind of object is literally the only thing that will work. Of course, I need to put some coefficients in one of these, so let's do that. Let's put some coefficients in front, and let's see if we can solve all of the coefficients. Well, the first thing is we need 2x squareds. So b times e must just be 2. And also, I can just, because this is factorizing, I can't use like 4.5. We're going to go with whole numbers. And so I can just choose b to be 2 and e to be 1. Because even if it's the other way around, I just end up with a solution, because I haven't said what any of the other coefficients are. This is called without loss of generality in maths. I can just assign this one to be 2 and this one to be 1, and I don't lose anything because it's just symmetrical to what it would have been the other way. So okay, that's fine. Now how do I make a minus y squared? Well, I need c times f to be minus 1. And there are actually 2 ways of doing that, right? You can either have c to be 1 and f to be minus 1, or the other way around. And now I can't just randomly assign those like I could with the 2 and the 1, because there's already stuff here that's causing an imbalance, right? They're no longer symmetrical because of the 2 and the 1. So what I need to do is I need to draw one solution where c is -1 and f is 1, and the other one where it's the other way around. And I need to consider both of these things now. Except when you consider this one over here, and you figure out the xy term, which you know is supposed to just be one of them, this time this is -2xy, and then this is plus xy, and you end up with a -xy term from this. So regardless of what's going on with D and G, this just is absolutely not going to work. We reject this because it doesn't create this, which is what I need. This one does. 2xy minus xy is a single xy. So we're going to continue with this because this is good. We're going to continue with it, and we're going to try and figure out the rest of it. So finally, we have that D times G must be -5. And there are quite a few ways to do that. 5 is prime, so there's not that many ways, but there are a few. You can either do -5 and 1, with D being the -5. Again, the order matters because the rest of the bracket is different. So D could be -5, G could be 1, or D could be -1, G could be 5, or this, or that. And probably the easiest thing to do is just put all of those in, exactly as I said, and then expand out and check which ones actually work, because we have one more piece of information here. We've checked that's correct, we've got that correct, we've got this, we haven't checked this yet. We've got this, of course, because I chose things that multiply to make -5, but let's check this, the -6y. So here, where are we going to get y's from? Well, we're going to have we're going to have -1y there, and -5y's there, so we're going to have -6y. So this works perfectly, and we just need to check how many x's we have to find our a, and we're going to have 2 times 1 is 2, and -5 to make -3 in total. So that's a completely valid solution, and a becomes -3. This one here, we're going to have -5y minus another y, so that also makes -6y, so this is also a valid solution, and the x's are going to be 2 times 5 is 10, -1 gives us a is 9. This one here, we've got y times -5 is, sorry, -y times -5 is plus 5y, and then plus another 1y gives us plus 6y, so we reject this solution here because it doesn't actually create what we want it to, regardless of what's going on with the x's. And this one we also reject because we have +1 plus 5 to make 6y again, so we reject this one as well. So I think these are the only two solutions based on my logic, and that's quite an interesting problem. I am going to set some extra work for you to do. Of course, I could just set you another one of these and say, find all the values a could be. I'm not going to do that. I'm actually going to do a more teachery thing, and this is just the teacher in me coming out. What I actually want to do, so these are the two, I don't know what this is doing, this is just rogue. I copied pasted a slide and forgot to remove this. These are the two solutions, ignore this, whatever. These are the two solutions with our A's. The challenge going forward, so just, you guys probably aren't teachers, most of you, but you can teach year 8s to factorize this, right? You can teach them to look for two numbers that multiply to make this and add to make this. You get 6 and 2, and they happily factorize it. And they can do that all day, right? They can work out 2 and 3 here, work, and they factorize. And after they've done that for a while, you can ask them a really interesting question, which is, you can ask them to write the question first, and then factorize it. So don't give them a question, just ask them to write the question, and then factorize. And the vast majority of the time, they're going to write some rubbish like this, because they don't quite appreciate yet that because the only quadratics you've ever shown them do actually factorize, they haven't actually appreciated that some don't, and they haven't really appreciated that you can't just pick any two random numbers and always have this one be the product of two things and this one be the sum, right? So actually what they work out after thinking about it a bit more, after doing this and it doesn't work, is you have to pick the numbers first, times them together to make the last bit, add them to make the middle, and then factorize to get the two numbers that you already picked. But I think this, kind of doing it backwards like this, allows someone to gain an appreciation for the thing, right? It allows the kids to gain an appreciation that you can't just factorize anything, and things that can factorize have to be built properly. And it allows for a better understanding of the thing that you're doing if you try and do this. So you can imagine what my challenge is now. And by the way, I sneaked this in. What you really want from them, although I've never managed to get this out of a year 8, what you really want from them is for them to write something like this, and even maybe this at the end, right? Because this describes everything that can be factorized, I guess. So yeah, anyway, the challenge for you guys then is, rather than just doing another question, I've shown you how to do it, so that's no fun, you can just do it now. Rather than doing that, can you write a question that looks a bit like this that gives 2 values for a? So can you write another question like this that's going to give you 2 values that you can then solve? If you do that and you don't find it too hard, can you write an expression just like I wanted my year 8s to do here? Can you write an expression or construct something that allows you to just find any number of expressions like this in which you can solve for 2 values of a? Of course, you could change it up even more. You could say, what if I wanted to write an expression that only has 1 value of a? Just like you could try and get a year 8 to write an expression in which the 2 numbers they use are the same. It's a bit like that, right? Can you write an expression where a is there's only 1 unique value that actually works? Could you write one where there's more than 2 values for a? Like, or is 2 the limiting factor? Could you write a question where there are no values? Right? I think all of these questions are super interesting, and if you spend some time thinking about them, you really gain a better understanding of the problem itself. So I'd highly suggest that you maybe have some time or spend some time playing around with that, because it is very rewarding when you try and figure some of these things out. Anyway, thank you so much for watching, and I'll see you next time.